Hello, grade 9 students. Welcome to the first EQAO prep video. Now, I am making this video for my students that incorporate a lot of examples that are similar to your Unit 17, but we are going to walk through specific steps and for the answers of certain questions. Okay, so let's begin. How many real numbers are between 0 and 100? Well, when we're talking about real numbers, let me just get my pen. We're talking about whole numbers, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're also talking about decimals, so numbers such as 0.1 or 0.001, 0.001. So there are infinitely many decimals in between each of the whole numbers. We also, when we're talking about the realm of real numbers, we have to consider irrational numbers as well, such as root 2 or pi over 10. These, as you've done the course, you've been introduced to a course of irrational numbers. So to conclude, there are infinitely many real numbers between 0 and 10, and the answer is A. Because you can always find more numbers between any two real numbers, no matter how close they are. This endless possibility is what makes the set of real numbers infinite and uncountable. So that's something to remember for the EQAO exam. Question number 2 has a series of statements, but only one of them is true about rational numbers. So let's actually start from the top up. A rational number in its decimal form is a non-ending, non-repeating decimal. Now, that is not a correct fact about rational numbers. The square root of any number is a rational number. That is not true because, for example, if I take the square root of 9, I get a whole real number, the number 3. So I know that statement is not true. And rational numbers are always positive. That statement is not true either. So the only statement that is true is that a rational number can be written as a fraction. So B would be the correct answer here. For question number 3, we have two sets. The set C, which we are told is the numbers 3, 6, 9, 12, and you can see that these are all multiples of 3. And set D is a set of that are multiples of 5. So we can conclude 5, 10, 15, 20, and we can keep going from that. So select the statement that correctly describes the numbers that are common to both set C and set D. And this is something that you need to understand if you're talking about maybe finding common multiples, common denominators, that sort of thing. When I really think about the 3 times tables and the 5 times tables, I know that the number 9 is not something that is common between the 3 times tables and the 5 times tables. I also know the common numbers are always odd numbers. Well, we can see that one number they would have in common, if I continued the 3 times table, would be 15. That would be that common. And we see here the common numbers are always multiples of 15. Well, when we go further, you will notice another common multiple will be 30 between 3 and 5. That is also a multiple of 15. And then the next multiple that they have in common is 45. So 30 is not an odd number. So I know C is incorrect because 30 is an even number. And obviously, we have already found a common multiple between the set of the 3 times tables and the 5 times tables. So D is also not correct. The only correct statement is B. Okay. Now we're going to move on to a question, scientific notation, which is something that you are introduced to at the very beginning of your grade 6, 7, 8 years in elementary school, but you might have come across in our high school curriculum as well. We want to find a number that is equivalent to the scientific notation form of 3.5 times 10 to the power of 5. And now when I teach this to my students, I always say, okay, start with writing 3.5. But in order to translate it into the real number, you need to start at the decimal and count 1, 2, 3, 4, 5 places. So including the decimal, that would include the decimal, the number 5. Well, actually, moving from the decimal to the number 5 would be 1 spot. And then we would have 1, 2, 3, 4 zeros. So that translates, because of course we have to ignore the decimal after we do that conversion. And that translates to answer C, which is 350,000. Question number 5 is a little bit tricky. You have to really understand your power rules in order to work this out. I would suggest starting, because we have X and Y variables, you want to first start with your X terms. When we start with our X terms, we can really break this down. We have to substitute 6, 7, or 9. You want to try one of those options is going to be the correct answer for the symbol square. So what I'm going to try is the number 9. I'm going to try the largest number. Actually, you know what? I will try, for the purpose of saving time, I'll try the smallest number. Number 9 is great. Now, if we break down the equation, I can see that x to the power of 6 multiplied by x to the power of a square. I'm going to substitute that with the number 9. I'm checking that if I multiply my powers and I divide by x to the power of 3, because I'm starting by only working with my x terms. So x, x, x. I'm leaving my y's for now, because if this is correct, my goal is, so I'm going to switch my pen, trying to get x to the power of 12. Now, my rule for the numerator multiplying powers means I have to keep the base the same, and I have to add my powers, so 6 plus 9. And then I have to divide that answer by x to the power of 3. That gives me, well, x to the power of 6 plus 9 is x to the power of 15. Divided by x to the power of 3. Again, we're going to keep the base the same. Now with division, I have to subtract my exponent, so 15 minus 3. And that does give me x to the power of 12, which was my goal up here. So I know for sure that the square symbol is going to be equal to 9. Race me a little bit over here. Give me a second. Now the y's are more simple because I'm just trying to come up with the answer. If I look at my y terms, I'm going to use that in green. I have y to the power of 3 times y to the power of 8 divided by y to the power of 4 to give me my final answer of what the triangle symbol is going to represent. So I don't have to actually substitute anything early on. erase. I figured out my circle. Now I'm going to figure out my triangle. That. Okay. So y to the power of 3 times y to the power of 8 divided by y to the power of 4. Just like before, I'm going to keep my base the same, add my powers, and then divide by y to the power of 4. So that's going to give me y to the power of 11 divided by y to the power of 4. Remember, my rule for division is keep the base the same and subtract my powers. So y to the power of 11 minus 4 is going to give me y to the power of 7. Therefore, my triangle has to be 7. Square symbol was represented by 9. The triangle symbol is represented by 7. So hopefully you were able to take detailed notes on that solution. You don't want to miss a single step. Now, number 6 says select the expression that has the value that is the least. We're going to come back to this question because we are going to have to use our power rules, our understanding of fractions to identify and really calculate this entire value to figure out which is going to be the greatest, which one is going to be the least. So we're going to come back to this question, question number 6. Question number 7, more straightforward. What rational number, we know rational numbers are also fractions, is equivalent to -5/6? So again, I'm going to have to tackle each question. I know right away that D has to be, we cannot reduce 5/6 anymore, and the answer has to be -5/6, so I'm going to cancel that out. 10/12, if I reduce that fraction, that's also going to be +5/6, so that cannot be the correct answer. For B, a negative and then another negative, 2 negatives. Well, 2 negatives side by side like that is going to be equivalent to +5/6. So that can't be correct. So the only correct answer is A, because if we reduce A by the common factor, if I divide both my numerator and my denominator by 2, my answer is going to be -5/6. So A is the correct answer here. Okay. Question number 8. This we're talking about temperatures, so it looks like we're talking about integers. The temperature is measured 5 times. The first temperature measured is 7 degrees Celsius, so that is +7 degrees Celsius. The temperature is going to then go down by 13. So it's going to go down by 13. I'm going to represent that with a -13. I want to solve that first. So you can see that, and I'm just going to cross out, I've done this part. So +7 minus 13. The signs in front of the numbers are different. So when they are different, I know that I'm going to subtract the numbers. I'm going to subtract 13 minus 7. Well, 13 minus 7 is 6. And then the sign of the bigger number is the sign that I'm going to keep. So the answer when we combine those two integers is going to be -6. The next integer that I have to take into consideration, it's going to go up by 4. So up by 4 means +4, right? When I do +4, again, different signs. So I have to ignore the signs and subtract. -6 plus 4, well, 6 minus 4 is going to be 2. And the larger number is negative, so the answer is going to be negative. Then the next part, down by 9 degrees, that's going to be -9. Now here I have two signs that are the same. So what I'm going to do in this particular case is add the numbers. 9 plus 2 is 11, and I'm going to keep the sign the same. So I get -11. And you don't see -11 here because there's one more step. We have to now go up by 1 degrees. So if we go up by 1 degrees, again, the signs are different. So I have to ignore the signs and subtract. 11 minus 1 is 10. The larger number is negative, so then my answer is also going to have a negative number. So the correct answer to this EQAO question is a -10 degrees Celsius. Okay, the last question for this video before we jump into pseudocoding is a little bit longer. So this question says that there are 42 students. Now, 6/7, 6/7 of the students are members of a school club. So what that means is, just the first part of this question, is that we have a total of 42 students. And if I multiply 42 by 6/7, we're multiplying fractions here, I know that 7 goes into 42 6 times. So that leaves me with 6 times 6, which gives me 36 students. So if 6/7 of the students are members of a school club, then 36 students are members of a school club. 36 students, remember that number. The next step is 1/4 of the students who are members of a school club are also members of the school environmental club. So out of the 36 students, 1/4 of them are going to be members of the school environmental club. It's another way of putting it. Now, the EQAO question that makes it a little bit tricky, this word not. How many of these students are members of a school club but are not members of the environmental club? Well, first we have to figure out how many members out of the 36, how many are members of the school environmental club? So to do that, we need to take my 36 students, I just figured out in the last part, and now I have to multiply that by 1/4. Now remember, 36 is a whole number sitting on top of an imaginary 1. Now I'm multiplying this whole number by a fraction. Well, I know that 4 goes into 36 9 times. So 9 times 1 tells me that there are 9 students that are members of the school environmental club. Okay, but if you notice that there's no answer 9, that's because the question is asking, and it would be tricky if they did put a 9 because that would be a way of tricking you. how many of these students are members of a school club but are not members of the environmental club? So it's up to me to know that if there are 36 students that are members of a school club, and I know the ones that are part of the environmental club, I have to subtract 36 minus 9 to get the right answer. So 36 minus 9 is equal to 27 students. So the answer is C. 20 students are not members of the school environmental club. So a little bit of logic with that particular question. Okay, I couldn't resist this distributive property question. I know that some of you have difficulty showing your steps for distributive property. So I want to tackle this question together. What is a simplified form of this expression? So I have negative 3x, a monomial, that is multiplied by a binomial, 4x squared minus 5. So I'm going to take negative 3x, and I want to show that I'm multiplying it by the first term because I'm applying the distributive property to multiply it by the first term. Now, those of you who struggled with this test is because the reason for that is you forgot to also multiply the monomial by the second term in the binomial. So negative 3x also has to be multiplied by negative 5. And to get the correct answer, you have to correctly multiply the terms. So I know that negative 3 times 4 is negative 12. I have x to the power of 1 times x to the power of 2. So the rule when multiplying powers is we keep the base the same and add the exponents. 1 plus 2 gives me x to the power of 3. For the second part, negative 3 times negative 5 is positive 15. And then I also have an x there. So we can clearly see that the correct answer is going to be D. And we have to incorporate our distributive property knowledge as well as our power rule knowledge. Okay, last question for part 1. We have to select the appropriate answer. So that means a little bit of distributive property, a little bit of just combining like terms. So I'm going to label this 1, 2, and 3, and let's work it out together. So for question number 1, 3n minus 4. Now, because there's a positive 1, I don't have to distribute an actual number, so I can just drop the brackets and combine like terms. So I'm going to choose to write the like terms, so next to each other. So 3n has to be combined with 1n, and negative 4 has to be combined with positive 2. When I combine the like terms, I'm going to get 4n. Negative 4 plus 2 is a negative 2. So number 1 is equivalent to the first column, 4n minus 2. For question number 2, we have to apply the distributive property. This time we have the constant number 4 multiplied by the binomial n minus 2. Now, even though this is a simple distributive property, I want to start off by taking the 4 and multiplying it by the first term, and taking the 4 again and multiplying it by the second term. So I have 4 times n and positive 4 times negative 2. Now, when I actually do the multiplying, you can easily see that this becomes 4n. Positive 4 times negative 2 is a negative 8. And the very last question combines a distributive property with combining like terms. This time, when you have a negative in front of the brackets, that does involve distributing a negative one. There's nothing in front of the first set of brackets, so I'm going to drop the brackets and put 5n plus 6. But instead of just a subtraction sign, I'm going to write -1 has to be distributed by the binomial n plus 8. So what that gives me is 5n plus 6. And I have to use the distributive property. So -1 times n and -1 times 8. Both of these have to be multiplied together. So we get 5n plus 6 minus 1n minus 8. To rewrite everything with like terms, this is going to give me a final answer of 4n minus 2. So I will check this box over here. Now stay tuned. I will be posting part 2 and possibly part 3 of this EQAO prep test.